Thank you very much. My name is Bryan Comer, a senior researcher at the International Council on Clean Transportation. I primarily study air pollution and air emissions generally from ships, from international ships, and my colleagues work on emissions from aviation and from passenger vehicles. The ICCT is an independent nonprofit research organization. We have offices in Washington, D.C., San Francisco, and also Berlin and now Beijing. We're most recently famous for accidentally uncovering the Volkswagen Dieselgate scandal through our research, and that with West Virginia University. So my colleagues work on passenger vehicles and I work on ships. And today I'll be focusing on explaining some of the trends in air pollution and greenhouse gas emissions from the international shipping sector, explaining a little bit more about what the International Maritime Organization, which Alice was talking about, has recently done in order to try and reduce emissions from the sector. And then now that we have this ambition, how exactly are we going to get there? So ships are a very efficient way to move things around the world, and more than 80% of the goods that we use every day are at some point on a ship. The issue with shipping is that not only are there great distances to cover across the ocean, but the fuels that ships use are the dirtiest transportation fuel on the earth. On the right-hand side of the screen is heavy fuel oil. This is the fuel that powers over 80% of the fuel consumption that's used by the industry. And on the left-hand side is distillate fuel, similar to diesel fuel that you would put in a truck. That's what the smaller ships operate on. So the vast majority of ships are using this heavy fuel oil. And in fact, this fuel that's on the screen today has been heated up to 60 degrees Celsius just to get it to flow. At room temperature, it's a solid. So this fuel results in a lot of air pollution. And this is a map that we've generated, which we've taken the satellite data from the ship positions, so we actually see where the ships are going. And we use that information to figure out not only where the ships go, but also how much air pollution they're emitting. And so you can see that ships are emitting not just in the open ocean, but are also heavily concentrated near shore, impacting local air quality. So we're worried about shipping emissions not only from a climate point of view, but also from an air quality point of view. When we're talking about shipping, there's a lot of different types of ships, but there are three that really stand out. And the ships that end up emitting the most emissions of carbon dioxide and other types of air pollutants are container ships. There's about 70,000 commercial ships operating any given year, and only 5,000 of them are container ships, but they represent almost a quarter of the emissions going forward. So any solutions that we're going to be talking about in the future need to address emissions from container ships, bulk carriers that carry things like coal for the time being, but also iron ore and grain, and then oil tankers, which are carrying petroleum products primarily. We'll see if they still are around in the coming decades. And it's also important from a policy point of view to understand that shipping is very much like the Wild West. If you have a ship, you can pay to have it flagged in any country in the world. And those countries that are offering the least amount of red tape are those that end up getting the lion's share of the ships. So you'll see on this slide that Panama, Marshall Islands, Liberia, these are quite small countries on a global scale, but they end up representing a large portion of the ships that are actually sailing the waters of the oceans. What's worrying to us is that, as Alice was saying, what we really need to be doing is we need to have emissions follow this red trajectory. This is the minimum that we can do to achieve the Paris Agreement goals. And really, if we were to hit this red line, that's assuming that the shipping industry is going to maintain its fair share of emissions going forward. And so what we're worried about is that the business as usual trajectory, this blue line, is continuing to grow in a time where it really needs to start decreasing. And so the question that we're trying to tackle is, given that shipping emissions are outside of the Kyoto Protocol, they're outside of the Paris Agreement, how do we regulate international shipping emissions? Well, we tried to do it under the Paris Agreement. These are my friends and colleagues from an advocacy group called Transport and Environment. They actually went to Paris with these homemade elephant masks and donned them. and they demanded that international shipping and aviation emissions be included under the Paris Agreement. These were the two big elephants in the room that really needed to be addressed going forward. The UNFCCC said thanks, but the Kyoto Protocol has been clear. The International Civil Aviation Organization and the International Maritime Organization are the UN bodies that are responsible for regulating shipping and aviation, and so they need to start developing their own rules. So a short 21 years later, after the Kyoto Protocol insisted that IMO and ICAO take action, IMO has taken action to try and tackle its emissions from the sector. So just a couple of months ago, an agreement on IMO's initial greenhouse gas strategy. It was agreed to on Friday the 13th, which I think is a little ironic, but we're hoping that it's not really unlucky. They've agreed to reduce their emissions by at least half from their 2008 levels. 2008 is the peak year for emissions, as far as we know, as far as we've been tracking shipping emissions. And then shortly thereafter, we had the global economic downturn. That's why you see that volatility past 2008, just at the top of that red arrow. And now we're on this emissions trajectory back up. As Alice was saying, there's a close relationship between GDP and emissions. And as GDP and as we recover globally, that is going to be driving emissions in shipping. And we really need to be following these alternative paths towards zero emissions. So ambition is nice, but how do we actually reduce emissions from this sector? And Alice alluded to this before. She called it slow steaming. And what it means is that you take a ship that's currently traveling at one speed and you slow it down. There's an exponential relationship between fuel consumption and speed. So if you slow the ship down a little bit, you slow the fuel consumption down even more and the emissions associated with it. We also need to make new ships more efficient. The reason why we're focused first on the existing ships is because ships can last for 20 to 30 years. And so if we've only focused on trying to make the new ships more efficient, we wouldn't really get anywhere in a time that's meaningful for climate change. Not only that, we need to completely change how we fuel these ships. No more heavy fuel oil going forward. The time for that is limited. In the future, we need advanced biofuels, we need hydrogen power, we need fuel cells, and we need to think about how we actually get from a ship that's wholly reliant on fossil fuels and burning the dirtiest transportation fuel to one that's truly zero emissions. In the time being, we can retrofit ships with wind assist technologies. Some ships are using kites and sails, but only a handful. And then my favorite are the Flettner rotors, which are those tall columns. They actually spin, and using the Magnus effect, they draw the ship forward, which I think is pretty cool. And lastly, zero-emission vessels. So on the left-hand side of the screen are some zero-emission ships that currently exist today. We have hydrogen-powered ferries operating in Belgium, and we have a zero-emission, completely battery-powered bulk carrier operating in China, which ironically is transporting coal 40 miles to a coal-fired power plant. But we do have those ships, and we're working on building the ships on the right, which are the larger ships, the ferries and the container ships that are the ones that are transporting people in cars, which car transportation across the ocean is actually a big source of emissions, and also the containers, which carry almost everything that we use. So I'll leave you with a couple of next steps. What we're focused on at the ICCT right now are developing the international, national, and subnational policies that are actually going to help achieve the goals that the IMO has set for itself in its initial greenhouse gas strategy. It's called an initial strategy because 5 years later in 2023, we'll be agreeing to a revised strategy. But that doesn't mean that there's nothing going on in between. In fact, there's a big push to make short-term actions and short-term measures that immediately and meaningfully reduce emissions from the sector. The first being slow steaming, slowing those ships down. And the next is trying to develop these alternative low carbon and zero carbon fuels and propulsion technologies. And there's actually some work ongoing now to figure out how exactly we pay for these new technologies. So I will leave you with that, and thank you very much, and I look forward to our panel discussion coming up.
Again, my name is Charmaine Chua. I am an assistant professor at Oberlin College, and I teach political science there. And so the perspective I'm coming from is really about thinking about the political, economic, and political social dimensions of shipping infrastructure. My own research is about the rise of just-in-time logistics and the ways it's produced sort of uneven effects on vulnerable populations. So I think what I want to try to do today is to get us to think about how shipping is not just about 2.2% of carbon emissions, because I think that does sound a little bit small. But once we actually zoom out to think about the broader conditions in which shipping came to be so consequential to the global economy, I think what I'm hoping to change our minds about is that there's actually a lot more going on there, and that the conditions of possibility for what we now know today as logistics and capitalism are actually sort of fundamentally enabled by the shipping sector. So that's a little bit of what I'm going to cover today. So let's start with what we do know, and this probably repeats some of the information. So a single container ship generates fuel emissions equal to that of 50 million cars. And so of the 760 million cars that are currently operating worldwide, they emit as much as sulfur as 15 container ships running at full capacity. And so if you extend that to the total global fleet of 5,000 container ships, that's a massive amount of fuel that's being generated. And I think Bryan also covered the fact that heavy fuel oil, when burned, also produces black carbon, which rains down and has been responsible for acid rain and especially sort of exacerbated effects on coastal regions. So all told, that's 1,000. Is 1,000 million a billion?
Yeah, a billion.
I think that's supposed to say 100 million tons of CO2 annually, sorry. So all told, that's I think, Bryan, do you know this? It's a billion tons, okay. I am not a proper scientist, clearly. And that's 2.3 to 2.5 of global carbon emissions totally. The IMO projects that it could be responsible for 17% of global CO2 emissions in 2050 if left unregulated. And if you counted that as a country, the total global shipping industry would be the 6th largest source of CO2, equivalent to about that of Germany, more than the UK, Canada, or Brazil. Now, whenever I say the statistic, people sort of, that's when it hits, right? That if you counted it as a country, it's really pretty significant. But I actually want to suggest that counting it as a country is precisely what misses the point. So on the one hand, we want an analogy that sticks, right, that makes sense to us. But on the other, I think the shipping industry is unique precisely because it's not like a country, precisely because it isn't regulated in the same way, and precisely because federal regulations can't really get at it. And so there are 3 aspects, I think, of what I want to talk about today that are going to sort of tackle that question. So we know that over 80% of total world trade travels over the ocean. And, you know, so Noel, 2 filmmakers called by the name of Noel Birch and Alan Sekula have called the ocean the forgotten space, right? It's this area that's sort of walled off from our imaginations. We don't see them very often. And in fact, as ports have developed further and further away from cities, they sort of are not part of the built environment that we interface with regularly. But in fact, they are so consequential to literally everything that we consume, eat, buy. And in fact, what shipping has done is actually enable the kind of just-in-time logistics, you know, expectation that we get deliveries as soon as we click on a button. So I'm going to cover 3 aspects of that forgotten space that we should strive to think about. The first is the legal and international dimensions, which I'll move through pretty quickly because I think that's been covered. The second is the question of its technical design and the way in which intermodal infrastructure actually produces effects on land that are pretty consequential. And the third is to think about container shipping as a site of politics and to shift the way that we're thinking about climate change, not just as climate mitigation or adaptation, but that we necessarily have to interrogate the capitalist conditions that have produced shipping as such, and that, you know, if that is the case, then we might want to think about climate change as a terrain of social struggle and not just a technological one. Okay, so the legal dimensions, as has been mentioned, is that no single country is responsible for climate mitigation when it comes to the shipping sector. It's a polycentric form of governance. And so what that means is that under international maritime law, there aren't really clear ways in which shipping emission reductions can be regulated or states can be held accountable. The murky jurisdiction of that law sometimes and often means that the states are the ones that are held accountable. But if you remember Bryan's graph from previously, where so many pieces of the pie are held by tiny countries, part of what happens is that a lot of states flag out in what the ITF calls flags of convenience, which essentially allows them to skirt regulations that otherwise, more, so to speak, regulated countries would hold them accountable to. And what that necessarily means is that the state-based enforcement mechanisms on which international maritime law apply don't actually apply in a space where the murky jurisdiction allows you to shift back and forth between different countries in relatively convenient ways. So all it takes, for example, to have a flagged ship under the state of Moldova is to have an office in the country, or even just a mailing address. And Moldova in particular, as a flag state or a known flag of convenience nation, for example, only had 88 detentions out of 590 flagged ships in the last year. So that's significant, right? These are 88 ships that don't conform to the kinds of laws that under the International Maritime Organization, climate change perspectives are sort of held accountable to. And we can talk more about that later. But the second, and this is what I sort of want to talk about a little bit more, is how the technical design of intermodalism sort of constrains or changes the calculus of how much shipping is responsible for. So how many of you have bought something online in the last 2 weeks? Yeah, and how many of you did it because it was just faster than going to the shop down the road? So it's crazy how our consumption patterns have changed, right? And really, I think this is arguable, but this has only really happened since the 1970s. And in fact, the 2-day delivery expectation really only started in 2002 when Amazon started Prime membership, and that has sort of started a whole sort of ensuing, effort to compete with Amazon. So I want you to imagine. Oh, that did not work. Okay, I'm just going to pause this. So this is a depiction of the global container shipping fleet, and the yellow dots are container ships. But this map is produced by an organization. Well, the website shipmap.org, and I highly recommend it. It's great if you click around. You can see the dry bulk carriers. You can see it by ship types and how much this stuff is generated. So they do amazing work. But so I just want you to picture for a second what it means to have bought let's say, the speakers that you purchased online this week, right? The everyday normalcy with which we expect something to arrive at our doorstep has actually taken a whole host of recalibrations and reorganizations of economic space. So the container is produced in China, let's say, travels across the Pacific, and what might be startling to those of you who live in New York is that even though you have a big port of New York here, 40% of all goods that are consumed in the US arrive at the port of LA. And that's because the trans-Pacific journey between China and the US makes much more sense without having to travel under the Panama Canal. And a lot of policy that has happened since then has actually aided land bridge transportation, or the ability for you to move those products from the port of LA to New York. So there's a surprising way in which it's not just shipping that is sort of at stake here, right, but the intermodal infrastructure. Okay, so speakers arrive at a port where over 800 trucks pick up and drop off containers every hour, and these are single can trucks, so they are sort of relatively not super efficient. And then, your product arrives at your doorstep by the friendly UPS guy. Okay, so what it has taken for that to happen is a whole host of really complicated recalibrations, which scholars are calling logistics today. And what logistics tries to think about is the optimization of each point, so that whereas you used to think about production sites, transportation sites, and distribution and consumption sites as relatively different, today those are sort of all optimized within a single circuit, so that what logistics managers think about is how to optimize the entirety of the global system as a field, which they can think about in terms of efficiency calculations. And so what you get essentially is the ability, what shipping allowed was the ability for you to produce your goods in China and ship them relatively at low cost across the ocean. Prior to the shipping container, longshore workers would have to handle things like bananas by the single bunch. And what the container essentially did was it wasn't just a form that boxed up goods, but it also one, it prevented weather damage. It allowed you to refrigerate the contents, therefore extending the life of the products that go within it. So for example, if you eat tilapia, or if you eat any kind of fish, sometimes they're caught in Alaska, shipped over to China on ice to be filleted, and then shipped back to you in the US. And so there's an extraordinary way with that the container has both sort of prolonged the life of what we eat, but also enabled it to be transported at a cost that it actually makes sense to use the lower labor costs of China than it does to actually, spend less money or do less carbon emissions to bring it just down the coast. And so carbon emissions aren't just about the sort of technical aspect, right? It's also political. And so when, the biggest difference I would say is that when the first container ship sailed, this is the Ideal X in 1956, it carried 18 containers on it. And today what you have, if you look at this chart, is that the largest container ship is 22,000 TEU. And these are called megaships. They really sort of strive to get efficiency gains, which actually happens to be also more carbon efficient. But the difficulty, and this is what I want to suggest, is that megaships also have these kinds of knock-on effects on places like ports. Okay, I've got 1 minute, so I'm going to go really quickly. So if you think about, so I want to just illustrate this in a couple of places. So what the megaship does is it essentially brings in what used to be, let's say, 5,000 containers at a time to 22,000 containers at a time. 22,000 containers at a time, and this is the largest ship that currently exists, requires a 100-mile line of trucks to unload, and these ships are larger than the size of the Empire State Building on its side, right? So these are massive. And what they do is not just achieve carbon reductions on the sea, but they also then produce a whole set of unfolding effects in the port. Ports now need to be dredged to be deeper. They also need to be, the trucks that sort of unload them also need to have more efficient spaces. And so what a lot of cities have ended up doing is produce efforts to sort of unload these trucks more efficiently. And that has caused, I want to argue, some really uneven effects on the poor and working classes. So I'm going to just illustrate this with a couple of examples. The Alameda Corridor is a 20-mile long corridor that runs under LA. It was commissioned as early as 1981, but completed in about 2005 and cost billions of dollars. Today it's in $4 billion of debt. But what's funny about the Alameda Corridor is it's this technological solution, right? And yet it's only run at 40% capacity now because the costs of running it are too large. The costs that they charge per company are too large. So what you have instead is highways that are still choked with single-can trucks, the ones that you commonly see around New York. And that has contributed, according to the California State Board of Health, to 3,700 premature deaths between 2002 and 2015, and what they estimate to be actually 18,000 premature deaths that are more broadly related to carbon pollution started by the ports. The Port of LA is actually responsible for 59% of all carbon-related emissions in the city of LA. So if you think about these kinds of unfolding effects, it's really not just about what happens over the ocean, right? It's also about the intermodal design and how it elicits a whole set of other things along the way. And then just really quickly, another example jumping across the ocean is the Port of Singapore that has actually engaged in a lot of what's called land reclamation. So if you look here at the pink and red sites, the pink is what has currently been reclaimed and the red is what's aimed to be reclaimed. Singapore has increased its land mass by 30% since its founding in 1965. And what that's actually meant is that it's had to import sand to the tune of 520 million tons from countries around the area, including Indonesia and Malaysia. And what's happened in the meantime is that researchers have shown that it's led to the disappearance of 24 Indonesian islands, to the depletion of marine and fishing life, that has led to huge dips in the income of fishermen who depend on those sources in Malaysia and Indonesia. And so, just to close up, I think what I want to suggest is that we really have to think about not just how we attend to the technocratic or technological dimensions of the shipping sector, but the ways in which shipping actually rises as a fundamental condition of what late capitalism requires of us, right? Which is to generate and demand a consumption-fueled life in which, buying our speaker and getting it delivered in 2 days is something that we expect. And what's sort of led to that and has been shipping in many ways. So I just want to end with a note, and I would love to sort of talk about community-based initiatives that do this work more, is that instead of thinking about climate mitigation, which is what the Paris Accords try to do, to think more about climate justice and what would require for us to actually prioritize a working class environmentalism or an environmentalism of the poor, and to take really seriously that the lives that get most hit by these carbon emissions are not necessarily ours, right? They're going to be the poor who live on the outskirts of cities who don't necessarily, aren't necessarily the first in mind, especially when market-based initiatives prioritize market priorities and market profit. So I'll end there, and hopefully we can talk more about this stuff. Thanks.